We are going to observe the Scanning Electron Microscope Laboratory at Lehman College of the City University of New York in the Bronx. The Scanning Electron Microscope, first developed at Cambridge, England, enables observations of surface structures of specimens. It is comprised of an electron optical column at the left and an operating and observation console at the right. Here, a small botanical specimen of pine has been mounted on a metal stub and coated with an evaporated layer of gold alloy to render it electroconductive. The specimen and stub is now fitted into a drawer-like assembly at the base of the optical column, which serves as a stage for holding and moving the specimen. The stage drawer is then inserted into place and the assembly closed tightly. By pressing a button, the operator activates a mechanical pumping system that evacuates air from the specimen chamber and the column of the scanning electron microscope. The pumps are located behind the microscope console. In combination with an oil diffusion pump, a high vacuum can be achieved in 2 to 3 minutes, allowing the microscope to be operated. First, a small video camera inside the specimen chamber shows the orientation of the specimen relative to the electron-optical components of the microscope. The specimen can be rotated, tilted, or laterally displaced. Using mechanical drives on the stage, the operator can position the specimen into a desired orientation. Then the operator can select an accelerating voltage, the electron beam current, to be used in observing the specimen. Now a changeover can take place from the internal video observation to a view as seen by the scanned electron beam. The beam is rapidly moving in a raster, and changes in magnification occur by changing the size of the raster implanted on the surface of the specimen. Magnification may range from a few times to over 50,000 diameters. At the same time, the operator can move the specimen to varying orientations relative to the electron beam raster. The image is, of course, electronically generated. The operator can select a given view of the specimen and have an electronically printed micrograph generated. Alternatively, the image can be directly imported to a computer or captured on conventional photographic film. The scanning electron microscope may also be fitted with a detector for X-rays. Here, a large canister of liquid nitrogen is used to cool an X-ray detector assembly fitted into the specimen chamber. When beam electrons strike the specimen, X-rays of different wavelengths and energies are emitted, which, when captured, are used to generate a series of peaks, each representing elemental information. Thus, while making magnified observations of the specimen, its elemental composition can be determined electronically.